Greetings. Today we are going to present our video presentation for the subject PHY310 Modern Physics. Our title is Nuclear Reaction in Stars. My name is Dayanku Nurizatul Najihah and I am joined by my group members. And I would like to introduce each one of them. The first member is me, second one is Nurauni Amira, third is Arena Vera, fourth is Debbie Vivet, and last one is Aruna Christina. And I will begin with the introduction. Nuclear reaction in star is a process where lighter atomic nuclei collide and combine to form heavier nuclei. First, stars are not just burning fire, they are massive natural nuclear reactors powered by intense gravitational pressure at their core. The main engine is nuclear fusion, a process where like atoms like hydrogens are smashed together to form heavier elements like helium. These reactions release immense energy, creating an outward pressure that maintains hydrostatic equilibrium and prevents the star from collapsing. However, this can only happen under extreme conditions, requiring temperatures over 15 million Kelvin to overcome atomic repulsion. We choose this topic because stellar nuclear reactions are the primary mechanism powering the evolutions of stars and the universe itself. Furthermore, it explains our origins. Every heavy element in the periodic table and in our own bodies was originally forged inside a star. Finally, studying how stars generate fusion energy directly guides modern physics in building clean, limitless fusion reactors on Earth. For our methodology, we started by thoroughly reviewing our PHY310 lecture notes to establish a rock-solid foundation of the core principles. Next, we use collaborative group discussions to break down complex formulas together and clear up any conceptual misunderstandings. We then expanded our research by cross-referencing our data with highly trusted digital repositories such as official NASA articles. Lastly, we utilize visual and conceptual breakdowns from reputable educational physics platforms like PBS Time to wrap up our learning.
For our fourth point, I would like to discuss the challenges encountered during research and our proposed solutions. The first encounter that we faced was the math and quantum complexity. This challenge involves dense equations and quantum mechanics like the Coulomb barriers, which can easily overwhelm an audience. This is because the actual physics, like quantum mechanics and how atoms overcome energy barriers to fuse, is full of scary and dense equations. If I put those equations on screen, everyone would lose interest immediately. To fix this, we shift from heavy math to conceptual explanations, using visual analogies for inputs and outputs. The next problem that we face is information filtering. This challenge, we have to sift through outdated stellar models versus cutting-edge data. This is due to too much information out there, and it was hard to separate old, outdated space models from the newest, most accurate data. To fix this, we cross-reference foundational textbooks with current NASA and peer-reviewed astrophysics papers.
Now I'm going to explain about the nuclear reaction in stars, which mainly involve the nuclear fusion. What is nuclear fusion? Nuclear fusion is the process where light atomic nuclei combine to form a heavier nuclei. These reactions occur under extremely high temperature and pressure in their cores, where nuclei can overcome electrostatic repulsion. In the stars like the Sun, hydrogen fuse to form helium through proton-proton chain reaction. And also, during fusion, a small amount of mass is converted into energy according to the Einstein's equation, which is E equal to mc squared. Importance of nuclear fusion. First is the energy production. Nuclear fusion is the primary energy source for stars, including our Sun. The energy formed by nuclear fusion is what makes stars shine and provides heat and also light. Second is hydrostatic equilibrium. They help maintain the balance between gravity and outward pressure inside stars. Without fusion, stars would collapse under their own gravity, leading to their destruction. And third is the cosmic impact. These energy and elements produced contribute to the cosmic cycle of matter, influencing the formation of new stars and planetary systems.
For the third point, I'll be explaining about the condition needed for fusion. The first one, nuclear fusion requires extremely high temperature and pressure. This is because high temperature gives nuclei enough energy to collide, while high pressure forces nuclei closer together. The second point is that nuclear fusion requires a high density. This is because high density increases the chance of nuclei colliding. Besides, greater density helps sustain continuous fission reaction. And the third one is nuclear fission requires longer time. This is because fusion occurs continuously over millions or billions of years. And the duration of fusion depends on the size and mass of the star. And for your information, massive stars use fuel faster and it can have shorter lifetimes than the smaller stars. Next, I'll be explaining about what happened during mass energy conversion. Mass energy conversions happen during nuclear fusion when hydrogen atoms combine to form helium inside the star. During this process, a small amount of mass is lost and converted into energy. Even though the mass loss is very small, but it produces a very huge amount of energy because of Einstein equation, which is E equal to mc squared. This energy is released as light and heat, which allow stars like sun to shine and stay stable.
For our next point, I would like to discuss the recent advancements or controversies such as the solar neutrino problem, which is resolved. The mystery is that Earth detectors originally caught only one-third of predicted solar neutrinos firing at flawed solar modules. The breakthrough is that neutrinos actually oscillate, meaning change flavor en route to Earth. This proves the nuclear models were right all along. Next, I would like to describe the core collapse supernova, which is an ongoing debate. The mystery is that standard physics simulations of dying massive stars often fail to produce a successful explosion. The frontier for this is that modern supercomputers use multidimensional fluid dynamics and neutrino-driven heating to solve how these stars actually explode.
Hi, I am Auni and I will talk about self-development nuclear reaction of star. For the topic reaction in star, first there are several areas related to modern physics such as astrophysics, nuclear physics, and space research physics. This career focuses on studying nuclear reaction inside stars and understanding how stars produce energy. This field is important because it helps scientists understand the universe and develop advanced technology for the future. Second, skill needed and career planning. To success in this career, strong knowledge in physics and mathematics is very important because research and analytical skills are also needed to study complex scientific concepts. In the short-long term, I plan to improve my understanding of physics and mathematics subjects. But in the long term, I hope to continue my study in astrophysics of nuclear physics. Thirdly is importance of continuous self-development. Continuous self-development is important because modern physics is always evolving with new discovery and technology. Scientists need to keep learning and updating their knowledge to stay relevant in this field.
Therefore, attending seminars, reading scientific journals, and improving research skills are important for career growth.
The challenges and strategies in pursuing career. First is the rapid scientific advancements. New discoveries are frequently happening, so we should keep on learning and stay updated. Second is the limited research facilities. Advanced equipment may not always be available, so we should continue on joining research programs and also internships. And last but not least is the complex scientific concepts. Topics like stellar nuclear reactions can be quite difficult to understand, so we should strengthen physics and also mathematics knowledge. In conclusion, nuclear reaction in stars play an important role in producing energy and creating elements that make life possible. Understanding this topic helps us learn more about how stars work and how the universe evolves. Remember, just like stars shine brightly in the universe, keep shining and reaching for your own dreams among the stars. Thank you.